Okay, let's take a look at how altitude influences the climate. And this is a topic that you need to know for your GCSE Geography course. How does altitude influence climate? There's two different things that you need to know. Number one is a thing called relief rainfall and the shadow effect. This one is a bit confusing of the two. And the latter, the altitude and changes in temperature, this is kind of common sense, it's really easy to understand. Let's take a look at these two things and everything you need to know for your course. So, the relief rainfall and the shadow effect. They're basically the same thing, it's just two names describing two in more detail. This is something that you can easily understand through a diagram, which I'll attempt to draw here. So we're going to have our ocean, and then we're going to have like our, what should I call this, our mountain. Okay, so this is our mountain. Hopefully it looks like a mountain to you. It's our mountain. And this is going to be our ocean. Our ocean. And this, so this is going to be the seaside, right? Our seaside of the mountain. And our land side. This is going to be our land side of our mountain. Okay, so what is really interesting about this is, and then another important thing, this is the direction of prevailing wind. So the prevailing wind is blowing to, prevailing wind is blowing towards the east. Now we also call the seaside. So that if the prevailing wind is coming from the left side, from our current perspective, we call this side the windward side. Pretty easy to understand, right? It's facing the wind, so it's windward. The opposite side, facing away from the wind, away from the prevailing wind, is called the leeward side. If I can write it. So the windward side and the leeward side. The windward side facing the prevailing wind, leeward side facing away from the prevailing wind. And what's interesting about the relief rainfall and the shadow effect and what really happens is the temperature around here is going to be approximately 20 degrees Celsius. So what's going to happen is it's going to evaporate. Water in our ocean is going to evaporate. So our moist, because obviously it's water, it's going to be warm, could be hot as well. Warm air rises. Now the temperature here is going to be approximately 20 degrees Celsius. Kind of like a relatively chill summer weather. So this moist warm air is going to rise. It's going to evaporate off from the ocean. And then, as this moist air continues to rise, eventually it's going to begin to sort of condense. So let me just delete this. Relief rainfall and shadow effect. We already know that now. So way up here, this water is going to start to condense. This warm, moist air that's evaporated is going to start condensing at 2,000 meters. And the temperature is approximately 7 degrees Celsius. And it condenses to form clouds. So the clouds are going to form way up here. When you have clouds and this warm air continuously growing, making more and more clouds, what do you think is going to happen? It's going to become rain. It's going to rain out here. Precipitation. So the moisture condenses as the air cools. As the moist warm air rises, it's going to condense as it cools. Humidity increases, clouds form, and eventually it's going to cause rain. This is called the relief rainfall. And then what happens is this cool air, depleted of moisture because it's just rained over here, right? So cool air, depleted. What does depleted mean? It means there is no moisture, or very little of it. Cool air depleted of moisture sinks and warms. So it's going to sink, right, if it doesn't have moisture. sinks, and it's going to start to warm up again. Because remember, the temperature is approximately 20 degrees Celsius. Cool air depleted of moisture sinks and warms. Relative humidity decreases. Relative humidity decreases. You might think I'm going really slowly, but if you go slow, it kind of helps you to understand. I recommend drawing out this diagram too in your notebooks. The moisture condenses. So relative over here, relative humidity increases because all this water is evaporated. It's going to be really humid, right? And it's going to condenses into clouds. And then now this cool air, once it's rained, it's going to deplete of moisture, it's going to sink, and warms, it's going to warm up as well, and relative humidity increases. Then this is what causes, right over here, the rain shadow effect. This kind of sounds cool, right? This was the relief rainfall. Let me write that here actually. Relief rainfall on the windward side, on the sea side. What am I writing? Relief rainfall. And over here we have something called a rain shadow. What does a shadow kind of imply? Well, it's the shadow of rain. So it's like the thing following it, there is no rain here, essentially. So there is very little precipitation. Remember, precipitation is just a fancy word for rain. Very little precipitation on the leeward side, the land side facing away from the ocean. Very little precipitation because the air is going to be dry due to lack of moisture. Lack of moisture. So obviously there's going to be no clouds forming on this leeward side, right? And it's going to be a dry, desert-like landscape. Essentially. So, to summarize, the ocean, 20 degrees Celsius, so the ocean water is going to evaporate off, and it's going to create moist and warm air. It's going to be very high in humidity, and it's going to condense as the air continues. As it rises, it's going to condense to form clouds. And at 2,000 meters, it's going to be approximately 7 degrees Celsius. And these clouds, as they continue to form, they're eventually going to cause rainfall, which is what we call relief rainfall. And this is all happening on the windward side, the sea side, facing the prevailing wind. And facing away the leeward, the land side, the cool air, now depleted of the moisture, is going to sink down. It's going to warm up, because remember, it's quite hot here. And the relative humidity is going to decrease down here. Because the rainfall, all the humidity, everything is on the oceans, the seaside, the windward side. There's nothing here. This causes a rain shadow. This is a key term you need to know. Very little precipitation, lack of moisture. It's going to be dry, and it's going to be a desert-like landscape. If we look at a bit of a fancy diagram, the reason I didn't use this is it just doesn't feel like you can understand it. If you draw it out yourself, it kind of feels it belongs to you, right? So I highly recommend drawing out something like this in your notebooks. But if we look at a bit of a nicer diagram here, our warm ocean, it's going to evaporate off, right? The hot air, it's going to evaporate. Moist, it's going to be very moist. Prevailing wind, remember it's flowing this way, right? Prevailing wind. And the warm moist air is going to rise way high up, 2,000 meters. Remember, it's around 7 degrees Celsius. It's going to condense, cool and condense to form our clouds. The rainfall, the precipitation is called our relief rainfall. And this is going to carry over to the other side, which is going to cause a rain shadow. It's going to be very dry here. Hot, dry, desert-like landscape. And it's going to cause a rain shadow on the land side, the leeward side. That's pretty much it for relief rainfall and shadow effect. But let's take a look at the altitude changes. And temperature. So essentially, what changing the altitude has to do with temperature. This is pretty much just common sense, essentially. Now we're gonna have our ground. It's gonna be our ground level, and let's draw some trees just so that we can visualize this a little better. We have our trees on our ground level, right? And at ground level, our air parcel, so our air here, Let me draw this a bit below, actually. It's like a parcel, a box of air. It's going to be approximately 30 degrees Celsius, right? We're going to go up to around, let's go to about 1,000 meters above sea level. So this is at sea level. 1,000 meters above sea level. How about sea level? Sea level. It's going to be around 20 degrees Celsius. So this is normally where your like mountains will be, 1,000 meters. Be a bit taller. Everest is like 5,000, I think. And we go a bit more higher. We're going to have our air parcel again. It's going to be 2,000 meters above sea level. And here it's going to be roughly, by the way, this isn't minus, this is just 10 degrees. Let me get rid of the dash, actually. 10 degrees Celsius. When we go way up, we can have mountains at like 3,000, right? It's going to be, what, even cooler. But essentially what happens is, as we rise in altitude, the air expands. Let me draw that again. As we go up, the air is going to expand. The air parcel, you notice them getting bigger. The air expands. And as it does that, it's also going to cool. As you go down, so as you go down in altitude, it's going to be the opposite. Air compresses and warms up. So at ground level, it's going to be around 30 degrees. As you go higher, cools down 20 degrees to 10 degrees. Pretty easy concept to understand, right? Let me explain it one more time using a bit of a easier diagram to understand. Let's draw a bit of a mountain again. A super tall mountain this time. Let's say this is Mount Everest. I don't actually know how tall Mount Everest is, but let's just assume it's 3,000 meters. So here we are, 3,000 meters above sea level. Here we are 2,000 meters above sea level. Here we are 1,000 meters above sea level. And we can have our sea level right over here. Sea level. So this is going to be the 0 level above sea level point. At sea level, might be 30 degrees Celsius. As you go up, maybe what, 23 degrees Celsius. Go even higher, 17 degrees Celsius. Third, maybe 10 degrees Celsius. So as you go up, the air expands and it's going to cool. So essentially, all you need to know, as you go up, the air is going to expand and it's going to cool down. As you go down, air compresses and it's going to warm up. That's why Mount Everest is like super snowy all the way up there, right? It's also why when you fly on your airplanes, it's like, what, minus 10 degrees out there when you're flying out there? It's super cold up there. As you go up, cools. As you go down, it warms. In physics, you might learn hot air rises, cold air falls. So you might assume it's quite hot up there. That's only in like closed environments, like in rooms. If you have a room with air conditioning, the air conditioning air is going to come down and the hot air is going to go up. In huge places like the Earth, as you go up, it's going to cool. As you go down, it's going to warm up. That's pretty much it for how altitude affects climate. Hope this helped, and thanks for watching.